Hi everyone, this is Dr. Mageshwari, Assistant Professor, Department of Mathematics, PPG College of Arts and Science. Today we discuss about relations for discrete mathematics. Learning objectives: understand the relations, learn representations, identify types, study properties, explore applications. Next, we go to the introductions. Discrete math deals with distinct values. Relations link elements of sets used in logic and computing, important in real life modeling. These are main objectives of introductions. Next, definition of a relation. R is a subset of A cross B. A cross B is a Cartesian product. Relation is a subset of Cartesian product. It connects the elements of two sets represented as a ordered pairs. Cartesian product A cross B is equal to set of ordered pairs for A equal to 1, 2 and B equal to x, y. So A cross B equal to A is 1, 2 and B is x, y. So multiplying each elements and each A elements and each B elements. So A equal to 1, 2 and B equal to x, y, 1, x, 1, y, 2, x and 2, y. So this is the ordered pairs of Cartesian product. This means A cross B. So basis for defining relations. Example of relation: A equal to 1, 2, 3 and R from the relation of 1, 2, 2, 3. So source elements of connection is a subset of A cross A. This is A to mapping A. It's a relation of A cross A. Representation of methods: roster form, set builder form, matrix form, graph form for the representation of these methods. Next, we go to the types of relations. Types of relations means reflexive, symmetric, transitive, antisymmetric, and others. So, reflexive relation, it means A comma A is belongs to R for all A belongs to A for every element related to itself. Like for example, 1 comma 1, 2 comma 2 and 3 comma 3, 4 comma 4, etc. This is called a identity relation also. This is for the reflexive relation. Next, symmetric relation. If A comma B is belongs to R, so B comma A is belongs to R. The mutual relationship. This is called a symmetric. A to B is B to A is a symmetric. For example, 1 comma 2 is obvious, 2 comma 1 is called a symmetric relation. So real life friendship, for example. Exact exclusive example is a real life friendship. Next, transitive relation. If A comma B and B comma C is belongs to R, this means relation, then A comma C is belongs to R. For example, 1 comma, this is for the triangle shape relations. For example, 1 comma 2, 2 comma 3 is getting from 1 comma 3. 2 2 cancels, we are getting from 1 comma 3. This is the logical connection. A to B, B to C is getting from A to C. This is for the transitive. Next one is antisymmetric relation. If A comma B and B comma A belongs to R, then A equal to B. So A comma B equal to B comma A equal to A to B. So example, this is less than or equal relation used to ordering. This is for the antisymmetric. Symmetric is A to B, B to A. But here less than or equal to, this is using for antisymmetric. Next, we go to the equivalence relations. Equivalence relations is most conditions are satisfied for reflexive, symmetric and transitive. These three relations are satisfied. This is called the equivalence relations. For group elements, for example, modular relations forms equivalence classes. This is the equivalence relations examples. Partial order relations for another one. Reflexive and antisymmetric and transitive. Equivalence is reflexive, symmetric, transitive. Partial ordering the same, but minimally change: reflexive, antisymmetric and transitive. For example, subsets conditions are used using hierarchies. Not all elements are comparable. This is the partial order relations. Next, the last one is applications. how to apply the relations for used databases, important in graphs, helps classifications, basics for functions, key concepts for discrete maths. These areas is covered by the relations applications. Thanks for watching.